In this video, I'm going to be doing a demonstration on how to graph a quadratic equation by hand. Now, when I'm looking at this quadratic equation, there's a few things I need to know. First of all, I need to remember what is the standard form of a quadratic equation. And the standard form is ax squared plus bx plus c. Now, the reason I need to know that is knowing these components makes my job a lot easier when I go to graph. Because the first thing I always want to do when I graph a quadratic equation is to find the vertex. Now, to find the vertex, I need to know a nifty formula. What I need to know is I need to know x equals negative b over 2a. And this b and a are the same b and a from the standard form of the quadratic equation. So for this one, I'm going to go ahead and label what's a, b, and c and use that to calculate my vertex. So a in this case is 1. When I don't see a number there, at least in front of a variable, I know it's a 1. My b here is negative 4, and c is 1. So for negative b over 2a, here's what I get. Let's do this right here. So it'll be negative, and then in parentheses, negative 4 over 2 times 1. So my b value is negative 4, so I substitute it here. My a value is 1, I substitute here. And so negative 4, let's see, that is 4 over 2, which is 2. So that tells me for my vertex that my x coordinate, see I say x equals, is 2. Now at the same time, that also tells me what my axis of symmetry is. I'll get to that in a minute. But to finish off my vertex, I need the y coordinate to go with my x. So what I'm going to do is I'm going to plug 2 into this equation. So I have 2 squared minus 4 times 2 plus 1. Now I'm going to use this as a time to look at how to use a calculator to do this. When plugging this in a calculator, use parentheses. It'll make your life a lot easier, and I'll show you why here in just a second. So I have 2 squared minus 4 parentheses 2 plus 1. And so my y-coordinate here is negative 3. So I have a y-coordinate of negative 3. And I'm going to go ahead and graph that. So that means I go over 2, down 3. That is the vertex. And the vertex is the turning point of a parabola. It's the maximum minimum. There's a whole bunch of different properties. But the nice thing about it is that this thing called the axis of symmetry divides the parabola into 2 equal parts, and it always goes through the vertex. My axis of symmetry is always x equals the x coordinate of the vertex. So, since I have x equals 2, I draw a nice vertical line through the vertex. And so that's the first thing I want to do is graph the vertex and axis of symmetry. The next thing I'm going to do is I'm going to make a table of values. Now my table of values I'm going to construct by choosing 2 values that are close to my vertex. Now since my axis of symmetry is 2 and my vertex is 2, negative 3, I'm going to pick 1 and 0. X equals 1, x equals 0 are both close to my vertex, so I'm going to choose that. And plus, if I ever have an opportunity to choose 0 to plug into equation, I do that. It makes things a lot nicer. So I have this x value. I need to find a y to go with it. So I'm going to plug in y into my equation. Now earlier I mentioned that using a calculator will make life easy. Let me show you why. Since I used parentheses earlier, all I have to do is scroll back and change my 2 to a 1, and I'm done. I don't really have to retype everything. So I get negative 2. I'm going to do the same thing with 0. 4 times 0 plus 1. So again, I come back here, and I'm going to change my 1 to a 0. Hopefully you already know what this is without using a calculator, but we'll do it just to be certain. And we get 1. So from my table, I know the point 1, negative 2. 1, negative 2 is on my graph. I also know the point 0, 1 is on my graph. 0, let's make it a little darker. I know those are on my graph. Now step 3 is to use the axis of symmetry to our advantage. I know that this side of the graph has to match this side. So what I'm going to do is I'm going to reflect. Now let me zoom in here a little bit so you can see what I'm talking about. So in order to reflect, here's what I'm going to do. I'm just going to count how far away I am from the axis of symmetry. I'm 1 away, so I go 1 on the other side. Up here, I'm 2 away, so I go 2 on the other side. Now notice I've made my nice U shape, my parabola, and I'm going to connect it as best I can, trying to not make it a V. Take a little bit of practice to do this. Just extend it all the way up. Let's get so you can see, extend all the way up. And if I want, I could put in some more values, make my graph a little bit more accurate. But if I wanted to be super precise, I would use a calculator to do it. So that's the first example of how to graph a quadratic equation by hand. Let's do one more example of graphing a quadratic equation by hand. Now, as you can see here, my quadratic equation looks a little different from my last example. Here I have 2x squared minus 3. And I've already written the standard form right above it so I can see the difference. If I notice, I have an a term and I have a c term. But there is no bx term in this case. And so I wanted to do this because it's a little bit different, but still the same, even though it's different. So let me show you what I mean. So our formula we looked at to find our vertex is x equals negative b over 2a. That formula still works even though I don't quote unquote have a b. I actually do, I just can't see it. Whenever we don't have a bx term, we know that b equals 0. When this is the case, life is really good. Let me show you why. So I'm looking at my vertex, I do negative 0 over 2 times 2. Well, negative 0 isn't really a thing, so I have 0 over 4, which is 0. That makes life pretty great. I know my vertex is 0 something, and I know my axis of symmetry is x equals 0. It always matches. The x-coordinate and the axis of symmetry always have to match. So now all I have to do is find the y-coordinate, and plugging in 0 is one of the best things ever, just because the calculations are easy. So I'm going to go ahead and do that. So I have y equals 2 times 0 squared minus 3. Like my last example, I'm going to use my calculator just because it'll save me a little bit of work later on. Hopefully you already know that this is negative 3. Hopefully you know that just by looking at it. But we'll come back to this in a second. So I get a vertex of negative 3, and I get an axis of symmetry is 0. So I'm going to go ahead and graph that on my grid here. So 0, negative 3, make it dark so we can see. Let me change colors here. Let's make our axis of symmetry. I'm going to put a little on the side so I can see that it goes through the vertex. So my axis of symmetry is right here. My vertex is there. Now we continue going with the table, like last problem. So let's see, I'll make a table. X, Y, and so I'm going to pick two x's that are close to 0. I'm going to pick 1 and 2 just because they're close, they're easy to work with, and hopefully will save me some time. So let's see, I'm going to plug in. So I have 2 times 1 squared minus 3. And I'll do the same thing down here, 2 times 2 squared minus 3. Now this is where my calculator comes in handy. Since I typed it in earlier with parentheses, I can just scoop back up, replace it with a 1, and voila, I get negative 1. Makes it kind of nice. Now if you type it in wrong the first time, that's where this can get messy, so make sure you check yourself mentally. So I'm going to plug in at 2, and I get 5. So I'm going to go ahead and sketch these points. I have the point 1, negative 1, so 1, negative 1, 2, 1, 2, 3, 4, 5. And I've got them on my graph. The last thing I'm going to do is I'm going to reflect them across the axis of symmetry. So again, like last time, I'm just going to count how far away I am from the axis. Well, I'm 1 away, so I go 1 on the other side. I'm 2 away, I go 2 on the other side. And there we go. Try your best to make it a nice smooth curve. It takes a little practice. So I come down, try and avoid making it a V, even though it's very, very, very tempting. And don't forget to put arrows on the end because this graph goes on forever and ever. So there are 2 examples of how to graph quadratic equations by hand. Hope this was helpful.